Actually, specifically endurance sports. So something about me, I am one of those crazy people that likes to run long distances. I like to run in all kinds of events and things like that. I, for whatever reason, enjoy getting super sweaty and going really far. This is me at a race earlier this spring. This was the Rock and Roll Half Marathon in DC. I don't just do running, I do other types of sports. So, for example, I do triathlons. This is me at a half Ironman in Raleigh, North Carolina. It's probably the hardest thing I've ever done in my life. These are all like endurance sports, right? But generally when we talk about endurance sports, we're really talking about running. That's the one most people think of, that's the household name. Running is great because it is a multidisciplinary, it's a very diverse sport. People of all shapes, sizes, ethnicities, backgrounds, genders can do it. And it comes in a wide variety of different race types. So the shortest one is the 5K, it's probably the one most people hear about, but I think the household name is the marathon. So I want to tell you a little bit about the history of the marathon. It started way back in ancient Greece. It commemorates the running of the Greek soldier Philippides from Marathon down to Athens. He was running to deliver a message about how the battle with the Persians went. And so in order to, the story goes that he went down, he ran this whole distance, he gets to the town square, and he shouted, "Victory! Victory!" and he held up his hand, and then he promptly died, as you can see here on the left. That's kind of a crazy thing. He died because of the incredible physical strain that that race put on his body. So for those of us who are training for these types of races, oftentimes the very first thing we try and do, especially if this is your first or second attempt at it, is really just try not to die. Like, just try really, really hard not to expire in the race. This is also, I think, why they give you a medal just for completing the race. Like, that's unlike any other athletic sport we have, where just finishing is considered an accomplishment. And I think that's kind of cool. So nobody would ever ask a marathon runner, like, "Hey, how did your marathon go? Did you win?" No, that's ridiculous. They'd say, like, "You completed a marathon. Congratulations, that's awesome." So I really like that about this particular sport. The next question people will typically ask you once you start doing this more often is not, "Did you die?" Clearly you're alive, you made it, but what was your time? And that's a really important question, right? That's actually the thing that people who do this routinely think a lot about. How fast could I do it? It's the exact same race over and over and over again, but now you're trying to figure out, how do I optimize? How do I get rid of a couple of seconds? How do I get rid of a few minutes off of my time? That's a big deal. And to make that point abundantly clear, they often will put a giant clock at the finish line, just so you know exactly how long that race was going to take. So time is a very important thing in these types of endurance sports. What I found is that people really enjoy that process of getting better. They really enjoy, like, going faster and trying all these different ways. That continuous improvement process is what drives a lot of athletes. And the great unspoken secret to doing really well is up here. If you want to get better at this sport, you have to go faster. You basically just have to run faster than the last time. It's simple, right? Duh! And to put it another way, the best athletes in the world at this, the people who are absolutely the top level people, are really good at going fast, right? What could be easier? But it's not quite that simple, right? I think we all know that. Once you start figuring out, how do I go faster? And how do I do that? You start coming into these other random questions like, well, okay, when I start going faster, I get more tired. How do I overcome that? I don't know, that's a tough question. When I go faster, I sometimes hit a top speed. How do I go faster than my top speed? These are the sorts of questions that top elite athletes think about and wonder and try and work through. But they understand that it's not just going faster. There's a lot of practices and techniques that they apply that help them to go faster. So they think about things like their nutrition and their training plan and things like how much sleep they get the night before a big race. All of those things play an important role in their performance, in how they go faster. Unfortunately, if you ask a bunch of top athletes, well, what's the best way to get faster? What's the best way to increase to decrease my time? You'll get a wide variety of answers. And there's not great consensus among the experts in this field about what the right thing is. Even something as simple as running form, everyone has a different opinion. And if you don't believe me, think about the great issue of our time that is dividing the running community. It is those weird footy shoe things that people wear versus traditional athletic sneakers. Some people think one is better than the other, and there's no real consensus or agreement on that. There's many ways to get better at this sport. So a couple of years ago, I started not just doing running, but I also started doing triathlons because I thought to myself, well, you know, one sport isn't hard enough, I should probably add on 2 more, and that way I can fail at all 3 of them. And that was nice. I really enjoyed that challenge. What I like about the triathlon community is because it's a multidisciplinary sport, there are actually, no one is good at all of 3 of those sports, right? No one is like, I mastered all 3 of these. No, a common question for triathletes is, what is your best discipline? In my case, it's running. This is great because it creates a community of people who say, well, I'm strong at one thing and weak at something else. Why don't we talk about that? Tell me what you think is better and how do you improve in that space? How do you get better when you bike or run or that sort of thing? And I started making this a practice. When I go to races, I'll find somebody who looks like they're knowledgeable and I'll talk to them. I'm like, hey, how do I go faster? How do I do better? So I distinctly remember this one event. It was very early on in my race career. I went to this event and I found this guy and I was like, that guy knows. Like, he looks like he's got this thing figured out. So I wanted to talk to him. And I knew he knew what he was talking about because he was wearing this helmet. That guy looks like a serious athlete, right? Yeah, he's a pro. And I said like, hey, I like your helmet. And he's like, thanks. It makes me go faster. I was like, great. I love going fast. I want to go faster too. How does it work? And he said, you see these dimples on the front of it? They lower wind resistance on my helmet. That makes me faster. And I was like, great. I had to go out and buy one of these things because I too want to go faster. And then I looked it up and it was like $200. And I said like, I don't have that kind of money. I can't afford that. That's crazy. So it made me realize I'm competing at a different level with this person, right? I'm competing with somebody who worries about the minutia of like wind resistance, and they're competing at a completely different level than I'm at. For reference, this is me at that race and my completely normal looking helmet. Hopefully you guys can see that in the background. I can assure you, wind resistance is not the problem I'm dealing with, right? That's not what's slowing me down here. Honestly, if I want to go faster, if I want to become better at that sport, the thing that I need to do is actually focus on the things that slow me down. Things like following a training plan, being good about nutrition, getting sleep, learning and improving my technique. Those are the things that will make me a better triathlete. So, okay, I took this big detour about sports and whatnot. What does that have to do with continuous deployment? So let me back up. As I mentioned, my name is Dan Davis. I work at Accela. We are a technology firm in the DC area. We work with federal and commercial clients to solve some of their biggest and most complicated problems. Specifically, at Accela, I lead large software teams. I'm a technical lead, and I am responsible for a lot of our technical execution. So I have a lot of hands-on experience in this space. Something you probably didn't know about our teams, we deploy to production hundreds of times per month. That's crazy, and that's like a mind-boggling number of deployments. And more importantly, I want to note, we do this hundreds of times per month. We do it in the federal government, and I do it on brownfield projects. So it's not some toy application sitting behind a firewall. This is actually things that impact customers and citizens, and they use it. So to put this number in perspective for you guys, if you're not totally familiar with the space, there's a report that comes out every year called the State of DevOps Report. And this report basically talks through, tries to differentiate highest IT performers and low IT performers and what their practices are. Just based purely on the number of deployments we do here, that puts us in the category of highest IT performers. That's the elites of the technology world. People who are competing with groups like the ones in Silicon Valley, so Google and Facebook and Amazon. That's the level that we're competing at. And I'm extremely proud of the team that I work for. They are genuinely smart, innovative people, and I love working with them. And I'm incredibly proud of the accomplishments we've made, and I want to share how we've done that and what we do in that space with everyone, because I want everyone to build software this way. Unfortunately, when I start having this conversation, when I start talking about my team and what we do, I get generally this reaction. Hey, that's really awesome for you and your team. Unfortunately, that doesn't really apply to us. Or we just don't do things that way. Or my organization will never be like that. I imagine that some people in this room are probably thinking that thing right now, and that's okay. Here's the thing. I am very keenly aware of the fact that coming here today, talking to you guys about continuous deployment, I probably look like that guy with the golf ball helmet. Like, I'm coming in telling you, hey, look, you gotta buy this $220 helmet to go fast. To be honest, I don't wanna be that person, and I don't wanna be that person for you guys. I wanna have a conversation around how we get better and how we go faster. If I could give myself advice, like way back then, I would have told myself to ask better questions of this guy, right? Go in there and say, like, how did you get started in triathlon? What was that experience like? And what people do you trust when you talk to about, nutrition, and who do you go to for advice? What types of mistakes did you make when you were going through your first couple of races, and how could you avoid those in the future? Those are the types of questions I wanted to ask. I think we've been having the conversation around DevOps wrong. We hold up teams and we say, like, look at the cool stuff that people in Silicon Valley are doing, or like, look at the accomplishments of this one team. Isn't that great? Look at what they're achieving. And it's normal for us to be envious of that and to say, like, yes, I want that too. I want to be like that team. But then we sort of are like, great, how do I do that? And what are they doing to make that happen? What are the practices there? How do I go faster? Well, it's complicated. Maybe you read the Accelerate book and you're like, great, 24 principles I can follow. But how do I implement those things? Those are hard questions. I think a lot of us are looking for a roadmap. That would probably be the easier way to think through this, right? Here's where I am and here's where I want to be. How do I get there? Give me the step-by-step instructions for how I do that. Unfortunately, that's also rather challenging because any generic roadmap we kind of put together is really influenced by your own company or organization's problems and challenges, and that's unique to each organization. So there is no one right answer. Just like if you ask experts, what's the right running form I should be using, you're not going to find a consistent answer. It's going to vary and it's going to be dependent on each person. I think maybe a better way to think about this problem is to ask a central guiding question. Something we can use like a North Star. Something that tells us, are we headed in the right direction? And we can periodically ask to gauge our progress. So let me suggest this. When you guys think about DevOps, today, tomorrow, all that, ask this question. What prevents us from going faster? Like, seriously, why can't we deploy more than once per month, once per week, every day? And what are the things that are holding us back? What are the organizational limitations that we're facing? What's the other process stuff that's in our way? Because once we know and can put a name to those things, we can figure out what the right combination of tools, techniques, and culture we need to apply to overcome those. That's how I want us to think about DevOps. So in that spirit of what prevents us from going faster, I have a question for you guys. Do you want to go faster?
Yes.
One more time. Do you guys want to go faster?
Yes.
All right, excellent. Okay, great. I know it's after lunch. It's a little tricky, but we'll get us there. Let's go through some continuous deployment basics, all right? So this is just level setting because I know we come from a wide variety of experiences and I just want to make sure everyone's on the same page. When I say continuous deployment, what I mean is every commit triggers a deployment to production. There's two key phrases there. Every commit or every change, and then a deployment to production. Okay, so I can model that. It's really easy. All right, here's what I've got. I've got a code repository on the left, and I've got a deployment to production process. I'm going to pay somebody to watch that code repository for changes, and when they see a change, they're going to scurry over to their laptop, and they're going to make a deployment to production. Continuous deployment, right? Nailed it. No, this is not continuous deployment. Now, usually when I bring this up, people will say, oh, okay, cool. I know that's not continuous deployment, but I do know what you mean. You mean automation, right? Automation, if we automate this process, that's continuous deployment, right? No, when people say continuous deployment, that's not what they mean either. There's all kinds of problems with this process. We can't just push things to production like that. Things like, well, should we just let any commit go to production? Well, we probably need some kind of an approval process. Where did our infrastructure come from? Well, I don't know. It's not represented here. What about testing? How do we know this is a good change? And what about monitoring? What happens after I put this thing into production? Then what? How do we make sure it continues to work? Let's think of it differently. So this means kind of the letter and definition. That's not probably helpful. Let's think about it this way. Apologies for the circles here, but this is our standard software development workflow. Every software shop has a flow kind of like this. Your mileage may vary a little bit, but in general, it's like this. So I make a code change, and what we're first going to run are like unit tests and static analysis. This is internal quality. Check to make sure that that thing functions the way that the developer intends it to. Once I've verified that, it's a good change, I'm going to create a build artifact out of that. This is a physical representation of the change. Maybe it's a jar file or a binary, or if you're using containers, it's a container image, something that encapsulates that change. After I've created my build artifact, what I'm going to do is I'm going to provision my infrastructure. I need a place to run that change. So I'm going to stand up whatever servers or infrastructure I need in order to make that change work. I take that build artifact and that infrastructure, smash those two things together. That is what we call a deployment, so running my change on infrastructure. And then I'm going to run some acceptance tests against this. So what that is a check of external quality, customer-facing quality. Does it do something useful for the people that we serve and the people that we work with? If we agree that's a good change, or maybe it's not a good change, we come to a decision point, right? That's where we make our choice. And that's that little blue box down there. So we say, yep, I'm going to promote this thing to production. It does something useful, and I want users to enjoy that. So if that's the case, I will provision my production infrastructure if it's not already there. I'm going to take that infrastructure and that same build artifact, smash those things together. That's my deployment. And then I'm going to monitor it. So I'm going to make sure I pay attention. What happens 5, 10, 15 minutes after I've made that deployment? How do I know that it continues to work? It's a very important step. Okay. So you'll probably notice this is kind of a generic workflow. Like, again, there's all kinds of variations, bells, whistles. In general, this is how people deliver software. Actually, specifically endurance sports. So something about me, I am one of those crazy people that likes to run long distances. I like to run in all kinds of events and things like that. I, for whatever reason, enjoy getting super sweaty and going really far. This is me at a race earlier this spring. Where? But this was the Rock and Roll Half Marathon in DC. I don't just do running, I do other types of sports. So, for example, I do triathlons. This is me at a half Ironman in Raleigh, North Carolina. It's probably the hardest thing I've ever done in my life. These are all like endurance sports, right? But generally when we talk about endurance sports, we're really talking about running. That's the one most people think of, that's the household name. Running is great because it is a multidisciplinary, it's a very diverse sport. People of all shapes, sizes, ethnicities, backgrounds, genders can do it. And it comes in a wide variety of different race types. So the shortest one is the 5K, it's probably the one most people hear about, but I think the household name is the marathon. So I want to tell you a little bit about the history of the marathon. It started way back in ancient Greece. It commemorates the running of the Greek soldier Philippides from Marathon down to Athens. He was running to deliver a message about how the battle with the Persians went. And so in order to, the story goes that he went down, he ran this whole distance, he gets to the town square, and he shouted, "Victory! Victory!" and he held up his hand, and then he promptly died, as you can see here on the left. That's kind of a crazy thing. He died because of the incredible physical strain that that race put on his body. So for those of us who are training for these types of races, oftentimes the very first thing we try and do, especially if this is your first or second attempt at it, is really just try not to die. Like, just try really, really hard not to expire in the race. This is also, I think, why they give you a medal just for completing the race. Like, that's unlike any other athletic sport we have, where just finishing is considered an accomplishment. And I think that's kind of cool. So nobody would ever ask a marathon runner, like, "Hey, how did your marathon go? Did you win?" No, that's ridiculous. They'd say, like, "You completed a marathon. Congratulations, that's awesome." So I really like that about this particular sport. The next question people will typically ask you once you start doing this more often is not, "Did you die? Clearly you're alive, you made it, but what was your time?" And that's a really important question, right? That's actually the thing that people who do this routinely think a lot about. How fast could I do it? It's the exact same race over and over and over again, but now you're trying to figure out, how do I optimize? How do I get rid of a couple of seconds? How do I get rid of a few minutes off of my time? That's a big deal. And to make that point abundantly clear, they often will put a giant clock at the finish line, just so you know exactly how long that race was going to take. So time is a very important thing in these types of endurance sports. What I've found is that people really enjoy that process of getting better. They really enjoy, like, going faster and trying all these different ways. That continuous improvement process is what drives a lot of athletes. And the great unspoken secret to doing really well is up here. If you want to get better at this sport, you have to go faster. You basically just have to run faster than the last time. It's simple, right? Duh! And to put it another way, the best athletes in the world at this, the people who are absolutely the top level people, are really good at going fast. Right? What could be easier? But it's not quite that simple, right? I think we all know that. Once you start figuring out, how do I go faster? And how do I do that? You start coming into these other random questions like, well, okay, when I start going faster, I get more tired. How do I overcome that? I don't know, that's a tough question. When I go faster, I sometimes hit a top speed. How do I go faster than my top speed? These are the sorts of questions that top elite athletes think about and wonder and try and work through. But they understand that it's not just going faster. There's a lot of practices and techniques that they apply that help them to go faster. So they think about things like their nutrition and their training plan and things like how much sleep they get the night before a big race. All of those things play an important role in their performance, in how they go faster. Unfortunately, if you ask a bunch of top athletes, well, what's the best way to get faster? What's the best way to increase to decrease my time? You'll get a wide variety of answers. And there's not great consensus among the experts in this field about what the right thing is. Even something as simple as running form, everyone has a different opinion. And if you don't believe me, think about the great issue of our time that is dividing the running community. It is those weird footy shoe things that people wear versus traditional athletic sneakers. Some people think one is better than the other, and there's no real consensus or agreement on that. There's many ways to get better at this sport. So a couple of years ago, I started not just doing running, but I also started doing triathlons because I thought to myself, well, one sport isn't hard enough, I should probably add on two more, and that way I can fail at all three of them. And that was nice. I really enjoyed that challenge. What I like about the triathlon community is because it's a multidisciplinary sport, there are actually, no one is good at all of three of those sports, right? No one is like, I mastered all three of these. No, a common question for triathletes is, what is your best discipline? In my case, it's running. This is great because it creates a community of people who say, well, I'm strong at one thing and weak at something else. Why don't we talk about that? Tell me what you think is better and how do you improve in that space? How do you get better when you bike or run or that sort of thing. And I started making this a practice. When I go to races, I'll find somebody who looks like they're knowledgeable, and I'll talk to them. I'm like, hey, how do I go faster? How do I do better? So I distinctly remember this one event. It was very early on in my race career. I went to this event, and I found this guy, and I was like, that guy knows. Like, he looks like he's got this thing figured out. So I wanted to talk to him. And I knew he knew what he was talking about because he was wearing this helmet. That guy looks like a serious athlete, right? Yeah, he's a pro. And I said like, hey, I like your helmet. And he's like, thanks. It makes me go faster. I was like, great. I love going fast. I want to go faster too. How does it work? And he said, you see these dimples on the front of it? They lower wind resistance on my helmet. That makes me faster. And I was like, great. I had to go out and buy one of these things because I too want to go faster. And then I looked it up and it was like $200. And I said like, I don't have that kind of money. I can't afford that. That's crazy. So it made me realize I'm competing at a different level with this person, right? I'm competing with somebody who worries about the minutia of like wind resistance, and they're competing at a completely different level than I'm at. For reference, this is me at that race and my completely normal looking helmet. Hopefully you guys can see that in the background. I can assure you, wind resistance is not the problem I'm dealing with, right? That's not what's slowing me down here. Honestly, if I want to go faster, if I want to become better at that sport, the thing that I need to do is actually focus on the things that slow me down. Things like following a training plan, being good about nutrition, getting sleep, learning and improving my technique. Those are the things that will make me a better triathlete. So, okay. I took this big detour about sports and whatnot. What does that have to do with continuous deployment? So let me back up. As I mentioned, my name is Dan Davis. I work at Accela. We are a technology firm in the DC area. We work with federal and commercial clients to solve some of their biggest and most complicated problems. Specifically, at Accela, I lead large software teams. I'm a technical lead, and I am responsible for a lot of our technical execution. So I have a lot of hands-on experience in this space. Something you probably didn't know about our teams, we deploy to production hundreds of times per month. That's crazy, and that's like a mind-boggling number of deployments. And more importantly, I want to note, we do this hundreds of times per month. We do it in the federal government, and I do it on brownfield projects. So it's not some toy application sitting behind a firewall. This is actually things that impact customers and citizens, and they use it. So to put this number in perspective for you guys, if you're not totally familiar with the space, there's a report that comes out every year called the State of DevOps Report. And this report basically talks through, tries to differentiate highest IT performers and low IT performers and what their practices are. Just based purely on the number of deployments we do here, that puts us in the category of highest IT performers. That's the elites of the technology world. People who are competing with groups like the ones in Silicon Valley, so Google and Facebook and Amazon. That's the level that we're competing at. And I'm extremely proud of the team that I work for. They are genuinely smart, innovative people, and I love working with them. And I'm incredibly proud of the accomplishments we've made, and I want to share how we've done that and what we do in that space with everyone, because I want everyone to build software this way. Unfortunately, when I start having this conversation, when I start talking about my team and what we do, I get generally this reaction. Hey, that's really awesome for you and your team. Unfortunately, that doesn't really apply to us. Or we just don't do things that way. Or my organization will never be like that. I imagine that some people in this room are probably thinking that thing right now, and that's okay. Here's the thing. I am very keenly aware of the fact that coming here today, talking to you guys about continuous deployment, I probably look like that guy with the golf ball helmet. Like, I'm coming in telling you, hey, look, you gotta buy this $220 helmet to go fast. To be honest, I don't wanna be that person, and I don't wanna be that person for you guys. I wanna have a conversation around how we get better and how we go faster. If I could give myself advice, like way back then, I would have told myself to ask better questions of this guy, right? Go in there and say, like, how did you get started in triathlon? What was that experience like? And what people do you trust when you talk to about, nutrition, and who do you go to for advice? What types of mistakes did you make when you were going through your first couple of races, and how could you avoid those in the future? Those are the types of questions I wanted to ask. I think we've been having the conversation around DevOps wrong. We hold up teams and we say, like, look at the cool stuff that people in Silicon Valley are doing, or like, look at the accomplishments of this one team. Isn't that great? Look at what they're achieving. And it's normal for us to be envious of that and to say, like, yes, I want that too. I want to be like that team. But then we sort of are like, great, how do I do that? And what are they doing to make that happen? What are the practices there? How do I go faster? Well, it's complicated. Maybe you read the Accelerate book and you're like, great, 24 principles I can follow. But how do I implement those things? Those are hard questions. I think a lot of us are looking for a roadmap. That would probably be the easier way to think through this, right? Here's where I am and here's where I want to be. How do I get there? Give me the step-by-step instructions for how I do that. Unfortunately, that's also rather challenging because any generic roadmap we kind of put together is really influenced by your own company or organization's problems and challenges, and that's unique to each organization. So there is no one right answer. Just like if you ask experts, what's the right running form I should be using, you're not going to find a consistent answer. It's going to vary and it's going to be dependent on each person. I think maybe a better way to think about this problem is to ask a central guiding question. Something we can use like a North Star. Something that tells us, are we headed in the right direction? And we can periodically ask to gauge our progress. So let me suggest this. When you guys think about DevOps, today, tomorrow, all that, ask this question. What prevents us from going faster? Like, seriously, why can't we deploy more than once per month, once per week, every day? And what are the things that are holding us back? What are the organizational limitations that we're facing? What's the other process stuff that's in our way? Because once we know and can put a name to those things, we can figure out what the right combination of tools, techniques, and culture we need to apply to overcome those. That's how I want us to think about DevOps. So in that spirit of what prevents us from going faster, I have a question for you guys. Do you want to go faster?
Yes.
One more time. Do you guys want to go faster?
Yes.
All right, excellent. Okay, great. I know it's after lunch. It's a little tricky, but we'll get us there. Let's go through some continuous deployment basics, all right? So this is just level setting because I know we come from a wide variety of experiences and I just want to make sure everyone's on the same page. When I say continuous deployment, what I mean is every commit triggers a deployment to production. There's two key phrases there. Every commit or every change, and then a deployment to production. Okay, so I can model that. It's really easy, all right? Here's what I've got. I've got a code repository on the left, and I've got a deployment to production process. I'm going to pay somebody to watch that code repository for changes, and when they see a change, they're going to scurry over to their laptop, and they're going to make a deployment to production. Continuous deployment, right? Nail it. No, this is not continuous deployment. Now, usually when I bring this up, people will say, oh, okay, cool. I know that's not continuous deployment, but I do know what you mean. You mean automation, right? Automation, if we automate this process, that's continuous deployment, right? No, when people say continuous deployment, that's not what they mean either. There's all kinds of problems with this process. We can't just push things to production like that. Things like, well, should we just let any commit go to production? Well, we probably need some kind of an approval process. Where did our infrastructure come from? Well, I don't know. It's not represented here. What about testing? How do we know this is a good change? And what about monitoring? What happens after I put this thing into production? Then what? How do we make sure it continues to work? Let's think of it differently. So this means kind of the letter and definition. That's not probably helpful. Let's think about it this way. Apologies for the circles here, but This is our standard software development workflow. Every software shop has a flow kind of like this. Your mileage may vary a little bit, but in general, it's like this. So I make a code change, and what we're first going to run are like unit tests and static analysis. This is internal quality. Check to make sure that that thing functions the way that the developer intends it to. Once I've verified that, that's a good change, I'm going to create a build artifact out of that. This is a physical representation of the change. Maybe it's a jar file or a binary, or if you're using containers, it's a container image, something that encapsulates that change. After I've created my build artifact, what I'm going to do is I'm going to provision my infrastructure. I need a place to run that change. So I'm going to stand up whatever servers or infrastructure I need in order to make that change work. I take that build artifact and that infrastructure, smash those two things together. That is what we call a deployment, so running my change on infrastructure. And then I'm going to run some acceptance tests against this. So what that is a check of external quality, customer-facing quality. Does it do something useful for the people that we serve and the people that we work with? If we agree that's a good change, or maybe it's not a good change, we come to a decision point, right? That's where we make our choice. And that's that little blue box down there. So we say, yep, I'm going to promote this thing to production. It does something useful, and I want users to enjoy that. So if that's the case, I will provision my production infrastructure if it's not already there. I'm going to take that infrastructure and that same build artifact, smash those things together. That's my deployment. And then I'm going to monitor it. So I'm going to make sure I pay attention. What happens 5, 10, 15 minutes after I've made that deployment? How do I know that it continues to work? It's a very important step. Okay, so you'll probably notice this is kind of a generic workflow. Like, again, there's all kinds of variations, bells, whistles. In general, this is how people deliver software. Well, what's important to me is that in this workflow, speed is an important variable. It's something kind of unspoken here. So depending on how fast I want to move through that workflow, I might actually choose different tools to get that done. So I might say, all right, if I don't care about how long that takes, all of those steps could be manual. Doesn't matter. But in general, people want to get through that workflow relatively fast. If you take nothing else away from this presentation, I want you to remember this. Continuous deployment is a speed. It's not a process or a tool. It is a speed. And importantly, it's the fastest speed we can go. It's getting through that workflow really, really, really fast. In order to achieve that speed, though, we have to work our way up to it, right? Very few organizations start with like continuous deployment. We have to work our way up to it. And it's been my experience that most teams and organizations have to work towards achieving that. I like to think of it kind of like shifting gears in a car, right? Nobody starts off in 5th gear. You shift through like 1st or 2nd, and then 3rd and 4th, that sort of thing. So taking that analogy one step further, we could argue that production deployments have like 5 gears. There's just convenient breakpoints for this. So there's 5 speeds of production deployment. Deploying once per month, deploying every sprint or every 2 weeks, depending on what your cadence is, deploying once per week, deploying every 2 to 3 days, and finally, on demand, every commit, or multiple times a day. These are the 5 gears of production deployment in my mind. And the rest of this presentation, I'm just going to kind of walk through, starting in the lowest gear, what are the cultural and technical challenges that we face when we try and shift from one to the next. So, let's talk about that. First gear. I assume many of you have worked in software shops that are in first gear or somewhere in that space, right? 1 month or less. For teams in first gear, I'm going to start us off by saying we have basic continuous integration. So they're running unit tests in some sort of an automated fashion. This is generally, most shops do this practice nowadays. But in just about everything else in that workflow is going to be manual. So the automated acceptance tests, they're going to be run by a QA team. The deployments, they're performed by a deployment engineer. Or our acceptance or servers, they get manually provisioned. So someone else does all of that work, and it may be outside of that team. As you can imagine, in first gear though, they run into a couple of problems. So your deployments are extremely prone to failure. You don't have a consistent process for it. It's done by different people, or it's done by a very small group of people who know how to do that. That's going to create all kinds of problems for you when you do deployments. Also, our deployments require downtime because we don't have control over our infrastructure. So we have to take those servers down. It's going to impact our users. That's going to be a huge issue for us. And it requires us to do those things late at night or on the weekends. Lastly, it's going to be, you're going to have problems with consistency between your environments. So something that works in our non-production environment but doesn't work in production causes all kinds of headaches for us because we don't have control over our infrastructure. First gear is not a great place to be. So, guys want to go faster?
Yeah.
Yeah, okay. GIF here, it was a dog riding a lawnmower. It is fantastic. You're going to have to use your imagination on this, all right? Okay, so dog riding a lawnmower speed. Let's talk about second gear. So you're going to move to deploying once per sprint, right? Well, why would you do that? Well, hey, we're agile. We're doing this whole sprint thing. And I learned in Scrum training that there is this potentially shippable product increment thing. Potentially shippable means I can push that to production. So this aligns really well with teams that are adopting Scrum in some capacity. For people in second gear, the big thing is their main limiting factor is going to be your deployment frequency. Like, if you do nothing about your deployments, your deployment failure rate is just going to double, right? If I change nothing about my process and I say, go faster, you're just going to double the number of deployment problems you're running into. So we have to deal with that. So the key difference between first and second gear teams is they have better automation around their deployments. Let's talk about that. So the first step in my mind is always just throwing in some automation. This is really where you're going to get the most bang for your buck, especially if you're just kind of dipping your toe into this. The tools to do this on the left-hand side are your classic configuration management tools. Tools like Chef, Ansible, and Puppet. These are sort of the industry leaders in that space. The advantage is they're also really great for configuration management, so dealing with your servers and other things like that. The downside is they often come with a high learning curve. This is not something you can just sort of pick up in an afternoon. This is something that's actually going to be a little more complex and require an investment of time to learn. On the right, if you're just sort of dipping your toe into it, you're like, we just want to get some amount of automation in place, you can use tools like Fabric and Capistrano. What these are is just deployment scripting frameworks. They literally just help you automate the manual script that your deployment engineers are running. And it removes the process of like logging into a server and running those commands. It's very lightweight and easy to learn. Downside for us is just that it doesn't scale particularly well. But it's a great way to get teams on board with automation and will always benefit you, just to have some level of consistency. It's also around this time that people are like, well, wait a second, I've been hearing a lot about like containers and like Docker and Kubernetes and the cloud. Like, shouldn't we take those things up first? Like, isn't that where we should be investing our time and our energy? Shouldn't that be the thing that we are driving to first? And I would just say, take this with a bit of caution. These are great tools to use, and they're well established in the industry for a reason. The challenge is they require a bit more of a significant effort to invest in, to get to transform your shop if you want to go in that direction. So they're good tools, just be aware that it's going to be a larger investment of time and energy to go in that direction. But if you choose to go that way, that's totally fine. All right. So if we automate our deployments, we're going to actually change our culture to some degree. I like to think of this as having a pipeline culture. What that means is our deployments are now going to be a multi-step process. So before we were just like, yeah, we deploy. Here's the thing, we deploy it. Deploy that version of the code. Now we're actually going to run two steps. We're going to test the thing, and then we're going to deploy it. That's going to create a small pipeline. It's going to be a dependent action. So the big change here is when we talk about pipeline failure. So a failure just means that step, like running your unit tests, for example, fails. If that happens, what we want is for it to stop our build. We don't want to deploy that particular change because something is broken or wrong. And if we were to fix that problem, we would want to restart from the beginning of the process. So instead of we see the problem and then we sort of push it along to make it go, we want to actually restart that process from the very beginning. This is what I mean by pipeline culture. This also comes with a bit of challenge for teams that are not accustomed to doing this. So the cultural change we want to see is, I want the team to react quickly when the pipeline is red, that is in a failed state. I want them to fix the issue. Many teams have a hard time with that. They're like, well, why would I do that? Why does it matter if that pipeline stays red for hours, days, weeks? Who cares? I have an automated process. I can just circumvent it and deploy using that automated process. So let me explain this one with an analogy on why we should care. How many folks in the room have a car? Show of hands? All right, great. I assume the rest of you take the metro. So what do you guys see when you see the check engine light, right? What do? We go to the mechanic, right? Maybe, sometimes, okay. But here's the thing. I think people in the room also probably smile a little bit and they're like, well, not always. Sometimes you just drive around with that on and like you either know somebody or maybe you are that person who has done that before, right? That's exactly the problem I'm talking about. Ignoring something that is actually a big deal. And the problem with doing this is if I ignore that problem for a long period of time, it just lets the problem fester. The problem gets worse and worse because I'm stacking up changes on top of that. And it soon becomes difficult to figure out what the issue is. So the better practice is when you see the check engine light, you take it to the mechanic. Same thing with a broken pipeline. You see the pipeline's broken, we only have a small number of changes we have to look through to see what was that caused that issue. Your car will thank you. All right, so in second gear, we've established a reliable build process, or a reliable deployment process. This is going to make our build engineers super happy because you have made their job easier, right? Imagine just saying, yeah, push the script and let it run. You go get coffee while that happens. They will thank you. It also makes it easier to recruit people to do this work as well. Imagine being asked, hey, can you just sit here and babysit this script, maybe just run this command, and let me know if something bad happens. That's really easy versus run all these commands, know what all these things do. It still has a lot of manual steps, but honestly, you should be able to hit that mark of deploying once per sprint. Great, but we didn't come here to just go, once per sprint. So, do you guys want to go faster? Yeah. Great, okay, let's go faster. And I had this adorable picture of this young lady doing a wheelie in her what is it, Power Wheel? Barbie car? All right. It was great. So third gear, let's talk about this. So you're shifting into third gear. The biggest limiting factor in this particular case, when we want to deploy once per week, is actually going to be your environment. This is surprising, because if we start deploying more frequently, we're going to have to start thinking about downtime and the effect of downtime. So in third gear, this is typically where teams run into that problem. Key difference between second gear and third gear teams: third gear teams have a much more sophisticated infrastructure management technique. They deal with their infrastructure in a completely different way. Let's talk about that. So what is downtime? I say this word, and sometimes I assume everyone knows, but just for level setting, if I have a service or a job running on a server, it's going to require, if I want to change the version of that, it's going to require me to turn that service off. That usually involves draining queues or stopping processes, maybe updating some packages. At a very minimum, it involves me changing the build artifact. But all deployments require some amount of downtime. That's just an immutable fact of what we do. So the common approach to dealing with that is, well, we have a maintenance window, right? We'll just have a maintenance window and say the server's down for now, it'll come back up in an hour. No big deal. But as we deploy more and more frequently, it's going to require us to have more and more maintenance windows. And I don't know about you guys, but as a customer, I've never been like, awesome, maintenance window. This is really great. Look how well designed this is. Look how nice it looks. No, nobody wants to see that. So how do groups like Facebook and Google and all of the other big companies deal with that? They use a better technique for this. They have a zero downtime deployment. So let's talk about a technique for that. We call this blue-green deployment. So here's the general idea. If I have a traditional application and I want to make this change, right? I want to change the version of this from version 1 to version 2. This is just a basic web application of some kind. In order to do that, it's actually going to require me to like turn that, stop receiving requests on that server while I make that change. That's going to impact users. That's going to make them very unhappy. Don't know how this will look. Well, let's see. Yep. So this actually gets a little messed up because we don't have animations. So you're going to have to bear with me on this one. I want you to visualize this in your head. What if instead of stopping the existing server, we actually just spun up a completely new set of infrastructure? And that infrastructure was already running the version of the code that we wanted. And once we'd verified that that version of our code was working appropriately, we just sent users to the other server, the new server. This is what we do for a blue-green deployment. We stand up new infrastructure running the version of the code that we want, and then we just tell it to go to the other server send all the traffic to the other server. The thing that's not showing up here without the animation is we would tear down server A. Like we would just tear down that whole infrastructure. And eventually we're just running one set of infrastructure, the new version. If you want to make another change, stand up new infrastructure, tear down the old one, switch over the users. What's nice is that this can be done in a way that doesn't impact users. It's so fast that users don't ever notice it, right? They just think that the website is giving the same result. So this is great. This is a way that allows us to break free of like maintenance windows and other issues. And this is one of many like zero downtime techniques. So once we have zero downtime deployments as a technique, we can usher in a different culture around deployments. I call this the daytime deployment culture. So this is great because I have a zero downtime deployment, I can deploy anytime I want, including the middle of the day. In fact, that's what I want to do. And I want to deploy even during peak hours because that's when my developers and my engineers and my team are awake. This causes a bit of culture shock, especially from people who have worked in traditional IT organizations for a long time. They say, whoa, wait a second. What if something goes wrong? What if you accidentally introduce a problem and it creates havoc in our system? That would be bad and that would be really embarrassing. We should only ever do our deployments in the evenings or at night. But this is an interesting problem. And this is how I generally address it. When we have issues in production, if we introduce a problem, we've done a lot of work to automate the process of making changes. So we can just introduce another change to fix it. We can actually fix it relatively quickly because we spent all that time automating our deployments and our infrastructure. We have a very reliable way to introduce changes into the system. And our engineers are awake at this time. They're doing their normal business hours. My whole team is here versus in the evenings or at 3 in the morning, I've got one person who's just sort of guessing and hoping to make it work. This is a way better situation for us, and it will almost always outweigh the risk that you bear. So, daytime deployments, a good thing. We should definitely do that. All right, in third gear, we have established a reliable build process that has no downtime. Great. We're using blue-green deployments and we're doing daytime deployments. That's going to make everybody a lot happier. We could even start potentially deploying to our non-production environment more frequently. There's nothing stopping us from doing that. And often teams adopt this practice. What I have found in my experience is that teams settle into a pretty good groove at like once per week. You'll find a lot of teams live in this space. They're like, yeah, this is great. It's a good cadence. We can kind of work our way through that, and the work week kind of creates a natural ebb and flow for us. So 1 week is a good spot for a lot of teams. But you guys didn't come here to go a very reasonable or safe speed, right? You guys wanted to come here to go faster, right? You want to go faster?
Yes.
Great. All right. So let's talk about this. What's funny is deploying every 2 to 3 days, this is actually where things get really hard. And it's kind of ironic because shifting into fourth gear, if you've ever driven a manual car, that's the easiest one. You just pull straight back. Unfortunately, not so. This is sort of where my analogy falls apart a little bit. What I have found is that gap to going from 1 week to 2 to 3 days is actually more cultural battling than any particular technology or technique. We'll talk a little bit about that. So why is this hard? Well, when you try and deploy every 2 to 3 days, your biggest limiting factor is going to be unfinished or unready code. This is where a lot of teams struggle because it's just, that's a really fast cadence to work at. There's barely enough time to develop something of use, and there's absolutely no time for manual testing. Can't be done. We don't have time for that. It's just too fast. So the key difference between 3rd year and 4th year teams, 4th year teams do very little manual testing, and they use sophisticated release management techniques like feature toggles. We'll talk a little about both of these. All right, this is your 1 week deployment cadence, something like this. So we have a couple days we spend doing development. We've got a day for like code freeze, bug fixes, testing, and then we have our deployments, and because Dan told us to automate our deployments, we go to happy hour afterward. Great, 1 week seems like an awesome place to be. What if we want to go faster? Well, here's the issue. If we condense that schedule down, we're going to run into a bottleneck, and that bottleneck is generally around testing, right? We want to give our developers as much time to develop. Testing is going to suffer as a result as we go faster. So is there a way we can make that better? Is there a way we could fix that problem? Yes, we can absolutely automate our tests, and there are a lot of libraries that help us to do that. Selenium is one of them. Here's the thing. This isn't a particularly hard problem to solve. The cultural problem is the big one. So who's supposed to write these automated acceptance tests? Am I saying that developers should write that? Well, here's the thing. Developers are probably better suited for it. They write code every single day, and they know how to do that. And traditionally, people who have the QA tester background don't generally have that automated skill set, right? It's less common to find that. But is it really fair for developers to be responsible for writing both feature and test code? Let me explain that with an analogy. So most of the major automotive manufacturers have what's called an engineer's day. That is, if you work on engineering a part for a car, you get to go down to one of the manufacturing plants where they install that part. And you spend a day on the line working with the men and women who install that part. This gives you a real tactile, understanding of every little bit about how you designed that thing. You feel a very tangible pain if you make a fiddly component that's hard to install. And it's supposed to instill a mindfulness about your code, or about your part that you've built. It's good for everyone to be able to see what that feels like and experience it, ask questions, and learn and improve, because when they go back to designing different engineering parts, they'll figure out, oh, hey, maybe I should rethink about it. Maybe I should think about how it's installed and why. It engenders a mindfulness about it. And this has actually been shown to increase quality significantly at all of the major automotive manufacturers. So by extension, I actually think it's very reasonable for developers to be responsible for quality. They should have a stake in that. They need to understand how users use the system and what types of bugs they run into and how to prevent those. I want them to understand and be mindful about the code that they're building, because they are uniquely qualified and empowered to fix that problem, right? Something that's very difficult and hard to test, well, maybe we should write a utility for that. Maybe we should re-engineer it to make it easier to test. Or we should build a utility to make that test data available so I can run through these tests. It's very important for developers to write the code, or write the automated tests. It also allows them to collaborate more closely with the product owner. So a product owner says, this is the acceptance criteria, and a developer understands what that is, versus throwing it over the wall to some QA team. So developers should write their code. Automate your tests. All right, fine. So we've automated our tests. We're in some sort of a continuous testing, continuous development cycle. Even if we automate our tests, we're still going to run into another problem, which is 2.5 days really enough time to build something useful? That's tough. And if you think it is, shrink that down to a day or some other small measure. There's a point at which it's just really tiny and there's not a lot of time to develop a thing. How do we deal with that problem? So let me give an example of this just to illustrate it. Let's say I have a feature I have a set of features that I want to put together. So it's 3 or 4 stories. I'm going to work on them, but for the sake of argument, we can't, as a team, complete all of them by the end of the cycle, in 2 to 3 days. But if I merge that code into my master branch, it's going to get deployed. And I can't deploy unfinished or untested things. So I'm kind of at a catch-22. I can't build it because then I'm going to end up pushing unfinished stuff into production, but I can't, I can't merge it in until it's all ready to go. This is generally where teams sort of say, well, hey Dan, listen, I know you were really excited about going fast and everything like that, but there is just a practical limit you are going to run into. Don't listen to that. That is a siren call. That is from people who will tell you that going slower is better for us. There's an easy way to solve this problem, and that's with feature toggles. So let me explain this technique. So feature toggles are just like a little tiny bit of conditional logic. Think of an if statement. And all it says is whether or not something is enabled or disabled. What's nice about this is I can set up a unique value per environment. This is usually associated with a cache or a database of some kind. And there are many off-the-shelf, like open source libraries that enable this depending on what your coding stack is. So a practical example of this, on the left I have my non-production environment, and I have a feature toggle. And on the right, I have that feature toggle, but it's turned off. Hopefully you can spot the difference between these two. If not, it's that search bar at the top. So the idea is the website continues to function and operate exactly as it's supposed to, continues to function exactly the same way, except it's just missing that one feature. And we can do that with coding and with feature toggles. So how does that solve our problem of the previous example? 4 stories, we couldn't get it all done. Well, here's what we're going to do. We have our non-production environment, and I'm going to put a feature toggle around those stories. And in production, that feature toggle is going to be turned off. So as I build each one of these various stories, it just kind of goes, in my non-production environment, I can see the result of it. I can test it. I can look at it, and I can get acceptance on it, right? I can show it to my product owner. I can demo it. But when I'm ready to, once all the features have been built, in my production environment, I'll just turn that feature toggle on. If I'm doing regular deployments, then that code has already probably been pushed to my production environment. And it's ready to go. All I need to do is turn the feature toggle on. This is amazing. This will change all kinds of stuff for your team. It also has a tremendous impact on your culture. So the big thing that's happening here is we're decoupling releasing functionality from doing a deployment. That is, we're replacing that with a feature toggle. So when I deploy to production, it's actually just this kind of unremarkable event. And that's kind of nuts. Everybody puts this big emphasis. When is it going to production? When is it going to production? Now the question we should ask is, okay, it's in production. When are we turning it on? When are we toggling that particular feature? This is going to be a big cultural change because we also place a lot of scrutiny on things going to production. But now we're going to have to shift and change that culture. It's really more about when the business decides we want to turn that feature on. We want to do that thing. This also has a nice benefit of making rollbacks pretty effortless. So if you think about, we introduce a feature and it causes something to break. Maybe we have an escape bug, something that we just didn't want. Well, we can just go in and turn that feature off and say, hey guys, there was this issue we reported, we decided to turn this thing off. Please go back to development on this. That makes your rollback pretty effortless. It's just the effect of turning something off. That's great. That means our mean time to recovery is measured in seconds. Now, I don't want to overstate what feature toggles can do, and there are caveats and challenges associated with it. But in general, I view this as a really strong practice for teams that are going with speed or teams that are dealing with this particular problem. All right, in fourth gear, we've got an automated testing process. We took it down from days or hours to a matter of minutes. That's great. That's going to help people. We are also using feature toggles. We're going to ship whatever we're ready to ship, and we're going to keep working on whatever's not ready to go. In fact, you should be able to really hit that sustainable pace of 2 to 3 days pretty easily now at this point. And there's honestly very little stopping you from going even faster. So, do you guys want to go even more fast, like with the most fast?
Yeah.
All right, great. Cool. I had grease lightning in here, so that was cool. Okay, so this is traditionally where we talk about continuous deployment, right? Fifth gear, deploying on demand or deploying on every single commit. Your biggest limiting factor in fifth gear when you deploy on demand is just efficiency. We've automated so much in our process. Really, this is just about getting a little bit better or making process improvements. So if you're not using containers to create infrastructure, great. Maybe this is a good step here, or it's a good time to apply that change. You also are going to run into that push button problem, that one last part of our deployment process that requires approval. Somebody pushing the button saying like, yep, send that to production. That's now going to become your bottleneck because everything else has been automated. So the key difference between fourth gear teams and fifth gear teams is that fourth gear teams use immutable infrastructure, so they have really good control over their infrastructure. They have sophisticated monitoring and alerting. We'll talk about some of those techniques there. And they flip the switch to automatically deploy to production. Let's talk. So even if we have a really, really, really strong test suite, even if we do exhaustive testing, there's still going to be a gap in our testing. And that is just essentially uncertainty. There are a lot of factors that we just cannot predict or don't know. For example, lots of stuff happens after we deploy our code to production. So things like, what if we suddenly get hit with a flood of users, right? A bunch of people come to the IRS website because it's, something goes on in the news. What if we have a memory leak that we accidentally introduce? We don't spot it during testing. That's a thing that can happen. What if we have an intermittent network failure? Nobody ever predicts the network failure, right? It just happens sometimes, and that's one of the great unsolved mysteries. Why does that happen? You just have to be able to deal with that. A lot of organizations use tools like New Relic or Nagios, New Relic being the commercial product, Nagios being open source, for monitoring. This allows you to gain some insight into what's going on in your application. There are a bunch of other tools in that space, but these are generally ones you can use to gain insight into what's happened. The big thing these tools provide is alerting. So what an alert is just a condition. Hey, I've got this condition that I want. When it's met, send me a notification of some kind. For example, if the number of errors that users are receiving starts to go up, the percentage of errors that my users are seeing goes above 5%, I want to be notified of that. I want to be told, hey, something's going on and you should probably look at it. And there's many audiences we want to inform. Obviously developers, right? Hey, guys, there's this problem in production. We're seeing a spike in error rate. Did we introduce a change recently that's causing a problem? What about the last couple changes we made? Is there something we didn't test or something else going on? We can analyze that and understand it and fix the problem. We might also want to give our product owner a heads up. I don't know if any of you guys are product owners, but if I were a product owner and my developers came to me and said, hey, just a heads up, there's something going on with the website, but you might start getting a bunch of calls and requests. They will really appreciate that, right? I want to be able to go in there and say, here's what's going on, here's what I know, and we're fixing it. That gives them the control to manage the stakeholders. So we want to make sure our product owner is kept in the loop on this stuff. We might also want to let the security team know. Hey, we just got a whole bunch of random requests from an IP address in Russia. That's interesting. They'll thank you for that information. They want to know more about that, for sure. So alerts can satisfy a wide audience of people. The important thing with alerts is that we want to be proactive about this. We want our system to tell us when we're experiencing a problem, not the other way around. We don't want to monitor constantly and just sort of watch the graph. We want it to say, hey, this is abnormal and weird. What's nice about this is I don't want to wait for my users to tell me that the system is broken. If they've done that, we've already lost. I want to be able to send that email that says, hey user, we already saw this problem. There's a fix going down our pipeline. It should be there in 15 minutes. This is actually an email I have sent before. And it's awesome. It feels great to be like, hey, just go get some coffee and come back in a few minutes. It'll be fine. That's a really, really solid system when you build it that way. Okay, fine. So we talked about monitoring. What's left? What's the last thing in our process? We've got this weird approval process. What would it take for us to switch that from an approval process to an automated process. It's actually not that hard, but you would not believe how difficult this choice is for most teams. It is actually a really significant cultural barrier. So are we even allowed to do that? Is that okay? Is that acceptable? Like, yeah, that's totally a reasonable question, and it's totally normal to feel a little bit afraid of that. Like, this is a big cultural change to say, our stuff will just go to this environment. So I asked my team members about this. I said, what was it like when we made this change? What types of, like, how did you feel about this, and what do you think it takes? And one of my developers said something insightful. He said, continuous deployment takes bravery. And I love that phrase. It takes bravery mainly because you have to trust that your automated tests are going to catch any major show-stopping bugs, because there's nothing else standing in the way of it. Your tests have to be your safeguard in that space. It also requires you to commit yourself to fixing problems. You're making changes frequently. So when people report problems, we have to fix that, mainly because we can. We don't have to wait. We don't have to wait for the next release cycle or the next, we can just fix that. That's great. That's a real power for our team. We can respond and adapt to what we learn. I will note that continuous deployment is a speed, as I said in the beginning. And I think there are trade-offs to going this speed. You can only really achieve that if you have a team that's competent and dedicated to making that work and really sort of embraces that culture and philosophy, right? You have to know what you're getting into, and you have to be okay with that. But if you're still feeling a little uneasy about it, don't worry. I have done this before. I personally lead a team that has been in this spot before, and we know how to do that work. And I am certainly not the only person who's ever done this. In fact, I'm really just building on the shoulders of other giants in the industry that have come before us and made these practices common. They've done the pioneering work to say, like, yep, these are the practices you should employ. So this is something that is well understood at this point. So when you're ready, just take a deep breath. And let's make that change. All right. Cool. That wasn't so bad, right? Great. We did it. Continuous deployment. That's how we get there, right? Awesome. Continuous deployment, all we had to do was go through all those steps. Here's the thing, though. So I have this weird question in the back of my mind. Just like, we did all this work. We're going fast. Does anybody still here want to go faster? Sure. Okay, great. I've got Thelma and Louise here, because usually this is like, well, is this a little bit too fast? Like, what's the point where we go too fast, right? Actually, I don't think that's really a concern we have. So taking it one step further, could we go even faster than that? Well, I think your main limiting factors at this point are just going to be that you don't produce enough, like you don't have enough, you don't produce enough code changes to actually run into a limit, or the other limiting factor is going to be whatever your longest step in your pipeline is. Doing some back of the envelope math, if your longest step is 5 minutes and you have an 8-hour workday, you can get 100 deployments in. My team doesn't come anywhere even close to that. And if we did, an obvious solution in this space is using microservices. So breaking that apart, making those modules more independently deployable. So most teams will never run into this problem. If you are experiencing that problem, come see me and I will talk you through how to deal with a ridiculous number of deployments. Okay. So we've done this. We've gone through the steps. We've talked a little about our roadmap. I do want to emphasize that this is one way for us to get from point A to point B. Right? This is hopefully a helpful guide in some respects about what you'll encounter as you try and go faster. But I understand that not everybody wants to jump straight to continuous deployment. And I hope that there's enough here for you to sort of pull back and say, okay, could we go a little bit faster? Could we go just a little bit better? What else could we do in that space? At the end of the day, I don't really care what speed or what gear you choose, as long as you're striving to improve, as long as you are focusing on a practice of continuous improvement. My name is Dan Davis. Thank you guys very much. I think we have time for questions, right?
I think we do, yeah. So we have time for questions. We have 2 mics on the left and right. I can either come and hand you the mics, or you can walk up to a mic, however you guys want to do it.
How you doing?
Hey, how's it going?
So, interestingly, I work on web apps, so web apps program, and according to your presentation, we're in half year. So we deliver every 2 months, okay? But I think we deliver the fastest of anybody in the IRS.
That's
I
awesome.
believe that's the case anyhow. So we have Jenkins, we're doing continuous integration and continuous delivery, but not continuous deployment, right? So we have Jenkins, Maven, and Nexus. We have Selenium. We're not using Ansible or Chef or Puppet yet, but we use AppScan. One thing you never addressed, which I do agree pretty much with your whole presentation, but is security. How have you, there's actually two things I'll say, a little bit more on testing. Performance and load testing, and security, and of course, like you mentioned, governance is the other thing, right? Because somebody's going to have to approve us to go to production. But the real deal is, and we use AppScan, and we do it every day. We scan our code for security issues, and we resolve high ones. We can't go to production with any high defects as far as security goes. So, and you say you do this in the government. Have you addressed that, or do you have some kind of software or anything you're doing that addresses the security and maybe the performance testing issues? We have a performance environment. We have a development environment. We have an AQT environment that we test in as well, and then of course a production environment.
Awesome. I'm really glad you brought that up. And it's one of the things that I hear a lot with this presentation, only because it's like, I have an hour and I'm like, I gotta cram all this stuff in there. So let me talk about security. I think this is a really great topic to bring up. Like, at what point in time does security fit into this? There's a lot of it is I want to move as much of security as I possibly can into the development context, right? So starting with something basic we can toss into our continuous delivery pipeline is, as you said, like static analysis and dynamic analysis of like packages. So tools like Nexus or AppScan, like doing some basic security analysis and looking for common vulnerabilities. There are tools that automate that aspect of it and are a good way for us to say, like, if we introduce new vulnerabilities in, we at least want to be aware of them and either block the build from going forward until we fix it, or at least set some kind of a tolerance or threshold. Depending on how fast you go, you might have more of a risk tolerance for like, hey, there was a new vulnerability issued. We're going to let you deploy that thing for a period of time, but then eventually we quarantine it and go away. If you're doing slower, hey, we deploy every 2 weeks, we deploy once a month. Yeah, we should make sure like we're not introducing new vulnerabilities in that space. The trickier bit comes when you're going really fast. What I really want teams to adopt is better threat modeling. So having an actual technique or an actual approach for how we secure things. So there's a movement right now called rugged DevOps, or rugged development, something in that space. But the idea is they say, okay, we believe that this is an important part of like training our developers. Do they know what common vulnerabilities are? Do we know how to remediate security vulnerabilities? And are they thinking about it when they actually design the application? So I'm building the architecture of something. I'm thinking about a feature I want to release, but do I actually take into consideration, well, do I need to secure this? What are our barriers to unauthorized access and other common things in that space? Does our project have documentation around just some of the common practices that we're adhering to? So many times when we use like cloud providers, they'll, like especially AWS, they give us a lot out of the box for free. So if you're trying to do like your, what do you call it? If you're trying to get security approval, a lot of times it's like, well, this is the common way that we're dealing with this problem. You know, we're using the AWS standard for this. So I think it's a combination of training for our developers so that they can be part of it versus, or even just integrating in a member of the security team. Say, you can be part of my cross-functional team. Your job is to educate my developers on what is important, what we should look for, what type of acceptance criteria we should toss in, that sort of thing. And periodically doing maybe a security review, once a month, that sort of, or once a quarter maybe. Say, here's the changes we made to our architecture, things like that. Those are just kind of common practices. They fall outside of the continuous delivery pipeline, but in general, we can get the low-hanging fruit with automated testing and scanning and whatnot, and applying general best practices. And then the rest of it is education, hiring people with those talents, and training our teams. Does that answer your question?
Yeah.
Awesome.
So for the part about the blue-green deployment and flipping things on and off and switching servers out, I've been looking for a reasonable answer to this one. How would that fit in with a database where you're making a schema change that has, millions of terabytes in it?
Mm-hmm.
You know?
I get asked this question a lot, and I actually really want to put together slides for this. Stateful infrastructure, particularly really, really, really big stateful infrastructure. So this can be a challenge. There's a couple of techniques in dealing with this. I'll go through just a few, but understand that there are a lot of different ways to deal with this. The general ethos that I think teams should adhere to is try really hard not to make breaking changes. So this is just about versioning and how we handle dependencies. I have a table and I'm going to rename a column. Rather than just renaming the column, I'm going to add a new column, change my model to point to the new column, and then I'm going to delete the column. 2 separate migrations. What people typically do is they break their migrations into 2 buckets, expanding sets and contracting sets. So with an expanding set, it's changes that I can safely make in advance of clients or other people using that service making their change. So I can run a migration and everybody should continue to work, and then they can move over. Contracting is the opposite. I have to wait for everybody to change over, then I can make my change. Knowing the difference between those two and educating developers on that saves a lot of time and effort. For really, really big stuff, you have a couple of options. Depending on your environment, you can say, if I'm using a managed service, sometimes it's better to say, I actually don't care, I'm going to let somebody else manage the restarting and the moving infrastructure over. This is typically what happens with RDS. If you say, well, I really do care about that, I do want to make sure that I'm making some kind of a big breaking change and I can't not make that change, you can stand up a second instance and then you can set up replication between the two. This works as long as that replication between the two is fast enough to keep up with requests, and in general, if you're working at web scale, or if you're like Amazon or Google, that won't work. So what teams typically do is they'll stand up 2 services and they'll write to both. So I have a database, it's got some new table that I want to put in. I'll change my model to write to both places. And I'll do that for a period of time so I can make a non-breaking change. Then once I'm satisfied that the data is consistent between those 2 databases, then I can spin the other one down and get rid of it and just say, okay, we made this cutover. Last technique we try is if you're using asynchronous messaging, you just build a queue and you say, okay, I'm just going to queue up, however many requests come in. So long as your migration doesn't take forever, it usually works out. So for a relatively small migration, something that takes maybe a handful of minutes. This is actually how Amazon does their shopping cart, for example. So if you've ever tried to buy something on Amazon, they'll say, hey, we've received your order. They don't say, you've paid for this thing. What they actually do is they put it into a queue, they send it over to the credit card processing, and then it runs, and then eventually if something goes wrong, they'll send you an email saying, hey, you need to update your payment, right? You can apply the same technique here in certain cases. So I'm going to queue up all the requests, saying, hey, thank you very much for your submission, we'll get back to you. And then that sort of queues up, and then once we've applied our change, the database comes back up, we can then say, okay, play all of those requests in, and then send out notifications as appropriate. So there's a whole bunch of techniques for handling stateful infrastructure. At some point in time, I will put together a presentation on all of them, but it's important to know that it's. I will note that sometimes the engineering effort of downtime, or the engineering effort to avoid downtime for stateful infrastructure is sometimes not worth it. So sometimes we're just like, yeah, we're gonna make this change. We could do all this engineering work to avoid downtime, or we could just do it at midnight and call it a day. I would say that should be our rare exception, especially in continuous delivery world, but we also have to be pragmatic about our resources, about our time, and where we spend our money. Hopefully that answers your question. Other questions? Go for it.
I think I can speak here. So I know you limit documentation in the continuous deployment agile world, right? But there is documentation, especially in federal space. So how do you address that when you're moving so fast?
Ooh, I love this question. So like, how do we address documentation in a world like we're in a highly structured environment? They're like, you need to tell us like how this stuff works. There's a couple of ways that we do that. One is just good standards. So anything we can apply, like formal documentation on security or like our general operating environment, things like that that are relatively static and don't change. It's reasonable for us to generate that documentation, to like work through it and say, okay, yeah, we're going to put this down and review it periodically to make sure it's up to date. Maybe after each release, maybe every 6 months, like that sort of thing, for things that don't change frequently, just to make sure that that stuff's up to date. For things that change frequently, I recommend automatic generation. This happens a lot with APIs. So there are tools like Swagger, where as a developer, I can annotate my code and then just have a step that generates documentation. So how does this service work? What are its inputs and outputs? What are its business rules? Like that type of thing. Automatic documentation is probably the best way to handle that particular problem when possible. The other thing is finding clever ways to automate the process or improve it. So one of the barriers that we ran into with going to continuous deployment in a government world was they said, you have to send us an email every single time you do a deployment, because we need to know what the release notes were for your deployment. So you need to tell us what's changed. That was fine when we deployed every 2 weeks. We just said like, yeah, here's the stories we're shipping, like no big deal. But when we started deploying hundreds of times a month, boy, their inbox got flooded. It was like crazy. And they said, I don't really understand, like, what does it mean, oh, fix that? Like that was the thing we deployed to production. It's just one commit message because it's such a small change each time. And what we did for them was we said, okay, let's rethink this process. Like, let's see if we can modernize this. What's actually helpful? Like, why do you want that? And they said, oh, well, we just want to keep track of like what's changing because we just generally like to know from a communications perspective, from a release perspective, that sort of thing. Creating visibility. Is that something we could generate each sprint review, right? I have people who are curious about that, and I have an opportunity to radiate that information. I should invite them to my sprint review and have them ask questions. What did you guys change this sprint? What did you ship to production this week? That's a great opportunity to change our process and embrace that. In other cases, we have to find clever ways to automate stuff. Sometimes it's getting developers to care about the process and getting them to care about the why behind it. So inviting people who need that documentation to speak to the team and like tell them about what your job is, because they're also problem-solving oriented people. And oftentimes they're like, oh yeah, I can make that happen. Like, we want to have a good collaboration with groups like that. We don't want to be in an environment where it's like, no, everything's magical, it works. Like, just trust us, the documentation, proves that it goes that way. So auto-generate it, find clever ways to automate it, or try and view static things less frequently, but be willing to document that. Does that answer your question? Cool. Go for it.
I just wanted to add one thing to what Dan said. When you actually use the code as documentation, essentially, which is what he's talking about, what that also points to is that in Agile, the way we communicate requirements between our business analysts and our developers is not by handing them the big stack of requirements documents, because then you've already written down what the rules are supposed to be. It's very often that we focus on having the conversation and having that very interactive relationship, and then documentation gets created as an after effect of that communication, so that both the developers and the requirements analysts, the business analysts, are part of that process that in effect generates the requirements in the form of acceptance criteria, maybe in the form of an attached spreadsheet that has some formulas or whatever it is. But the handover, the key in Agile is the collaboration between those two groups, and then the documentation falls out as an after effect rather than as the means in which these requirements and specifications travel down the pipe. Does that make sense?
Yeah.
one of my observations in this space is that almost, I would say maybe half the cases, a good information radiator is what people are actually looking for. So I have a project manager who's like, what are you guys building? What are you guys working on? What stopped? Like, I could document that in an email but sometimes I want to point them to self-service information. So can I make that information visible to somebody? And can I provide a way for them to look that up? This happens a lot with metrics too. People are like, how many times did you guys deploy to production? I could do the manual work of figuring out, or I could just build a page that says, like, it gets updated every time we deploy and resets itself each month. You know, providing ways for people to access information on their own both enables the business to like get smarter about what's going on and enables like good processes and governance, but it also like makes our developers smarter about what things we care about. So we have an information radiator for our KPIs, right? And in the case of one of my projects, it was like, how many cases were approved? What's the percentage automatically approved? And we have a threshold. We want that to be like above 98%. That's our goal. Great. Like our team members can see that and the effect of the changes that they make. Sometimes we don't meet that target because they make mistakes. And that's like a really valuable thing for them to see, like, yep, this is what they care about and we're not doing it. So, yes?
When you're going that fast, do you even bother to uniquely identify each release?
Technically, yes, but it's usually an auto-generated number. So there's a fellow I met at a conference, Mark Shahad, who said it was like, we have to do major, minor, and patch version number. And he's like, we are on version 2.0.478. And I was like, great, yes. It's basically that sort of problem. They say, what's the unique identifier number of this thing? You know, it's like, well, here's the, we have a pipeline ID that we automatically generate. Or like, here's the build artifact that we deployed on this system.
Because like the documentation issue here is not just about, can I learn what's in the release? It's also about, can I pass an auditor's request 3 months down the line about what happened on what day and why did it happen? So
And
that's part of the challenge.
Totally. And giving people the access to like that information. So, hey, I can give you access to our Jenkins server. I can spend time with you to help you understand like where would I go for this information? How are we capturing that? And collaborate together to figure that problem out. And maybe even have a small amount of documentation about it. Here's how we would find that information. In the ideal world, maybe a developer could even write a script to pull that automatically. If we know like it's a well-formed, like auditors ask us for this every 3 months and it's a pain in our rear end. It's like, great, let's build a tool that makes that better. Yes?
Good afternoon. You had mentioned earlier one of the techniques you used in your development capacity was expansion and contraction.
Mm-hmm.
And part of that, I got the information with the expansion as far as duplicating and trying to minimize what you change before you actually remove some functionality.
Mm-hmm.
So I didn't get the contraction portion. I got the expansion, like when you gave the example of building a table and adding an additional column before you remove one. But I didn't get the concept when you said contract.
Cool. Yes, so with an expansion set, like think about, so I have a table and I want to rename a column. If I add to that table, if I add a column, that's an expansion set. Mm-hmm. If I remove the old column, that's a contraction set. So expansion sets, as you pointed out, are, I can make that change and then users or clients aren't impacted by it, right? Until they make their change. So it's safe to push that to production, it's not a big deal. With contraction sets, it's the opposite. And the reason is because if I remove a column and I have 3 clients that are trying to access that table, right, then they will be pointing to a table that doesn't exist anymore, or they'll be pointing to a column that doesn't exist anymore if I make that change. I would rather they drop that information from their model.
Oh, okay.
So they have to.
Before you remove the functionality.
Exactly. So once I have consensus that all the applications that use that particular thing have like made that change, then I can go ahead with my migration, or I can make that change. This also applies to things outside of databases, like APIs and versioning and that sort of thing. It is generally a good practice to follow. Other questions?
Is there a guidance
to know what is the right gear for specific project deployment?
Ooh, that's a great question. So is there guidance for which,
Or metrics, I mean, based on,
I'll say what they can do, they can't hear
say it one more time before the microphone,
I'm
please.
gonna sing now. No, here we go. Now, the question is there a guidance or a metrics to determine what is the right gear for a specific project or process?
So I have a bit of a biased answer, which is I think fifth gear is the right gear for every project until proven otherwise. Let me explain that one just a little further. So the fastest gear. Basically, I think continuous deployment should be the practice that everybody applies, just because I like working in that environment. I think there may be, unless you work in something, okay, so one of the things that people try and tell me is to say, well, what if we're risk averse? What if we're in an industry where like, I work in a nuclear reactor. I make a mistake, then like bad things happen. The thing is that people will say, well, this is the risk. So in order to do, I am going to be extra cautious, and I'm going to sort of slow things down to make sure that we don't make any mistakes, because mistakes could be disastrous. In my mind, that's actually irrelevant of how fast you go. It's more about how you architect your system. And people who are like worried about that are just architecting their systems poorly, right? I had a person in the Air Force say, are you saying that planes are gonna fall out of the sky if we have problems? I was like, well, I mean, I don't think we should design our system so that if there's an error, like planes fall out of the sky. That sounds terrible. But if planes are falling out of the sky, at least I could push a fix up to maybe get them to fly, as they're falling. The point just being, I can either introduce risk into the system, a small amount of risk frequently into the system, or I can have one giant big ball of risk that I occasionally plop into our environment. We just kind of cross our fingers and hope that it goes. This happens a lot when we talk about like change failure rate. This is one of the metrics I sort of have a love-hate relationship with. An analogy I'd use is, imagine you are comparing fire departments, right? So I have two fire departments. One of them comes up to us and says, here's the deal, we have thousands of houses that we serve, and we respond to 12 fires a month. And our time to getting to your house is about 10 minutes, right? We can be there in 10 minutes. That's our average response time for that. Great. You have a different fire department that says, we have a couple hundred houses that we respond to, and not a single one of them has ever caught on fire. Which one of those fire departments do you want to serve your house? I don't know. I would rather have that first group. The people who respond to fires regularly, the people who understand how the system works. It's just a different way of viewing risk, right? We can either take a stance that says, we would prefer to just like check and make sure everything is great and everything is good before we push this thing out the door. But I don't think that reflects a modern reality. The world changes and the world shifts. We're no longer in the business of building products. We build experiences for users. So our users, we have no idea how users will react to certain things, or at least it's very difficult for us to know with accuracy. I would rather have a system that allows me to say, let's just see what happens if I push this out, and let me learn from that experience and get a little bit better, or tweak the response based on it. So if I deploy once per month, then I'm just gonna guess, and I'm stuck with it for a month. If I do continuous deployment, I can guess and be wrong, and it's like, great, I'll fix that, and then push out a change to fix it. There's different ways of viewing risk, but in my mind, everyone should go faster. Everybody should take that stance of, we prefer to make small, frequent changes. One more analogy in this space. There's a key difference between the SpaceX and NASA. So NASA has an amazing track record for safety. They do extremely complicated work, and space flight is one of the most difficult things in the world. SpaceX is a startup that is private, and they're doing all kinds of really innovative work in the space industry. But they blow up a lot of rockets. I had something like 75 flights this year, And many of them didn't work out. You know what they call those? Learning events. They said, we learned from the fact that like when we fire the rocket off this way and it tries to land, it does this weird, bizarre thing, and that rocket blew up. But we learned from that, and what they're doing is driving out uncertainty from the system. And that's a really, really powerful thing. So what we want is to be in a world where we say, I know for certain how that rocket is going to react in all kinds of conditions. I've tested it, I've fiddled with it. I've introduced a lot of changes, and I've tested that. Versus saying like, well, you have a lot of procedures, you have a lot of like, we've done a lot of thinking in this space, and we've only got a couple of successful flights to tell us. Does that make sense? Did that answer your question? I'll get off my soapbox. I think that everyone should go fast. Everyone should go to continuous delivery at least. So 4th gear, 5th gear.
So it's not based on the content of the feature, specific feature. Because at one point, I mean, you need to make sure when you deploy into production or to test environment, it's something that has value, it's a feature, something actually the content. So, and I think, at least in iOS, feature is quantified. It's not a small feature. There is rules there is process. There are business rules that have to be executed. There is a lot of effects that takes place. So the development, to develop that feature might not be necessarily 2 days or 3 days.
So let me give a story on this. I hear what you're saying. I hear this a lot too, right? Like the problem is we develop big features and we have things that are complicated. I think everybody craves that like big win. Like we're going to push this thing out and it's going to be this big thing. One of the mistakes that my project made was there was a major piece of modernization we wanted to do. And we spent 9 months working on it. We had continuous deployment at that point. We were going fast. We were making all kinds of changes. It involved the integration of our system with several other systems, systems that were moving slower than us, systems that didn't really understand what they were doing. And there were all kinds of organizational factors and things like that that came together. And boy, we worked our butts off for this thing. And when it came time to push that thing across the finish line, we had to push it back a month. Even though we were going fast, even though we were doing really, really great stuff. So it was really frustrating for us because it was like, well, I thought we were supposed to be, lowering our risk. Our components worked really well, but this release was very complicated and hard and buggy for us because we had to collaborate with lots of different groups. We did a similar release for a different part of the application. We changed our strategy. We said, what if we replace one component of this system, right? And we're just going to make it so that we can run these things in parallel for a bit of time. We call this shadowing or a canary release. So we were able to route traffic to it. It was basically, we have a decision-making engine that says whether or not someone is approved for a benefit or not. And we believe that the engine that we were building would give a better result. So we ran them in parallel. We said, we're going to introduce this change, we're going to run these things in parallel, and we're just going to see what happens. We're not actually going to record the new result. We're just going to kind of observe. What does it do? We learned a lot from that deployment because some things didn't work out. Some things gave us false positives. That was really bad. If we had released that to production, we would have run into all kinds of problems. It probably would have been on the Washington Post. But we said, no, there's some things we need to fix in this. Once we were confident with that new release, we said, okay, what if we start routing some traffic to that? Maybe what we'll do is when the first decision engine gives a no, we'll run that against our system and see if you get a better answer. So we're running a small percentage of traffic there, only the no cases, just to see what happens. And even then, we said, we're just going to shadow and see what happens, just a little bit. We learned a lot from that, right? There are many conditions we hadn't thought of, hadn't dealt with. So we went back and iterated on it. Then we said, all right, we are confident this thing will work. Let's turn this on and it will now start overriding decisions, right? So we turned that thing on, we said, yep, we're going to override this now, but only a small percentage of traffic. Just see what happens, right? And verify that's correct. We did that over a course of a week. We ramped up. We said, okay, we're going to start showing more and more traffic to this. Same system. We were able to introduce that in a way that not only didn't break it, but minimized our risk. We were essentially doing the same type of deployment we were doing with that big 9-month monster release thing. And we were able to do that in a way that was like, did you guys deploy this weekend? It was like, yep, we sure did. And people were like, great. I didn't notice anything happen. Where's the party? There's like, not a big deal. We turn that thing on, you know. Well, when is it going to be done? Oh, continues. Like, we continue to iterate, tweak it, make it better, you know. But in my mind, that's the better way to release things in high-risk environments. Even if it's like, we have to treat everyone the same. We have to build rules that, you know, we follow. We have big things we're trying to build. There are release management techniques that allow us to get the risk out of the system and just sort of build it differently instead of just sort of dropping it into production, which is, I think, the traditional way we think about it. Like, hey, I'm just going to push this out and be there. So we can break these things into smaller bits, even if it's not necessarily like perfectly, like, here's one item that the director of the institute will be able to talk about. You know, we can make that, we build towards that. You know, this is our business release, this is our big goal, but we're introducing features all the time. Does that make sense?
It does.
Cool.
There's a great example that I read about in Facebook before they introduced Messenger. They actually deployed code with the latest releases that with Facebook, before they released Messenger, they were concerned with lag times about, you know, messages being fast enough and it was supposed to be instant. So apparently they deployed code with updates of Facebook where people had no idea there was any Messenger aspects in there at all, but under the hood, these different apps sent messages to random other apps just to make sure that they could address the technical aspects of the lag time. These messages had no content. They were not sent by users. They were sent out by the application, but they were able to collect data on how quickly those things went through the network and were registered in the other app and all that kind of stuff. And they had, by the time they actually released Messenger to the users and made it visible in the interface, they had tons of data and had resolved several technical issues about how to make that user experience productive. And I think that speaks to the same thing that Dan was talking about.
Yep.
And it's a little bit like feature toggles, except you actually turn part of it on. You just don't necessarily make it visible. But it's for that learning to flush out that uncertainty.
One of the things I'm always amazed by with the DevOps space is that we are constantly coming up with new ideas and new techniques. I learn things every single year, and it's sort of like, how do you keep up with all of these different techniques and different practices? And the only way is really like asking for advice, talking to others who have success, talking to others who don't have success, and learning from their mistakes. But if we create an environment of continuous learning where we share our ideas, we talk about the challenges we face, we talk about things that are hard between our different organizations and how we can figure those out, I think everybody wins in that case.
Like, finally, to the phone. Does anyone on the phone have any questions? Okay. Are we good here?
I'm happy to stick around if anybody wants to chat more, but thank you guys very much for coming.
Thank you.
If anybody wants stickers.
I'm glad you know.